Law of Sines, the ambiguous case. In this lesson, you will learn how to apply the law of sines to solve triangles given side-side angle. We already know our law of sines and why side-side angle cannot be used to prove triangle congruence. Remember that with side-side angle, we have three situations. We always have an angle, a fixed side, and another fixed side. So let's look at our three cases. We could have this fixed side swinging to the left or to the right, which gives us two triangles. In the second case, our second fixed side is longer than our first fixed side, so it's not going to let us create two triangles. It'll only give us one triangle. And in the last situation, our fixed side is too short. Our second fixed side is too short to create a triangle, so we have 0 triangles. So in this problem, we're going to solve triangle ABC given that angle B is 48 degrees, side B is 9 feet, and side A is 24 feet. So we set up our law of sines, and we solve for sine of A by multiplying both sides by 24. And then we can put that into the calculator, and we get sine of A equals 1.9817. Hopefully we remember you cannot have a sine value of greater than 1. So that is not possible. If you try to put that into the calculator with the inverse sine and our 1.9817 to get the angle measure, it will give you error. And if you were to draw the triangle, it looks like this. So there are no such triangles. Number 2, solve triangle ABC given angle B is 43 degrees, side B is 11 feet, and side A is 7 feet. So here's our drawing. We set up our law of sines, solve for sine A, and we get 0.4772. That looks good. It's less than 1. And so we can use that. So we use our inverse sine to find the measure of angle A, which is 28.5 degrees. So we can see that we can make a 28.5 degree angle there. And now we need to find all the missing pieces. But first, let's check and see if there's another triangle. If we take 28.5 away from 180, we get 151.5 degrees. So these two have to add up to 151. And if you add 151.5 to the angle that we already know, we get 194.5. So if you take this angle, 151.5, and add it to the 43, we get more than 180 degrees. So there is only one possible angle here that we could have. So only one triangle exists. And then we solve for the rest of the missing pieces. So 180 minus these two angles gives us 108.5 degrees. And then we can set up our law of sines using that 108.5 to find side C. So our answers are 28.5, 108.5, and 15.3. The last situation. Solve triangle ABC given B is 55 degrees, side B is 23 feet, and side A is 25 feet. So set up your law of sines, and we solve for sine A, and we get a number that's between -1 and 1, so that's good. So then we can find the measure of the angle, and we get 62.9 degrees. So we have our picture down here, and we can label what we know. And here's our side for the angle that we just found. So that's A sub 1, and we can write in that 62.9 degrees. Now we take that and subtract from 180 to see if there's another triangle that could be drawn here. And when we do that, we see that we get 117.1 And when we add that to angle B, we get less than 180 degrees. So there are two triangles here. Now the reason that we subtract from 180 is because when we know that these two side lengths are congruent, so this little triangle right here would have to be equilateral, which means that this angle would have to be 62.9 degrees also. And these two angles right here have to be supplementary. So this one would have to be 117.1, and then we would add that to this 55-degree angle to see what the measure of this angle could be. And because we got less than 180 degrees, we know that that angle does exist. If it was 180 degrees or more, we couldn't create this second triangle here. So to find this angle right here, this C sub 1 right here, we subtract 180 minus the other two angles, and we get 62.1. So right now we're focused on this bigger triangle here. This is our triangle ABC sub 1. And then we solve for side C using our law of sines. So these are the three answers for the large triangle. This should really say A sub 1. All right, so now we have the second triangle. And we know that our angle measure for the second triangle was 117.1, and then when we add that 55, we got 172.1. So these two together are 172.1, which leaves this one to be 7.9. Then we can set up our law of sines to find this side C right here, and we get 3.9. So this angle measure right here is 7.9. This little side right here is 3.9. This angle right here is 62.1, and this side right here is 24.8. So those are our answers for our two triangles.